Okay, so here we are in section 12-3, and this one is analyze geometric sequences. And the one thing you need to know about analyzing geometric sequences is that they, instead of being arithmetic sequences, when we say the word geometric, I want you to think of like multiplying or powers. So where arithmetic was adding, geometric is multiplying all the time. So when sequences get bigger, it's because they're times 2 times 2 times 2 instead of plus 2 plus 2. So in a geometric sequence, it's a sequence in which the ratio of the term to the previous term is constant. So we're going to go constant, and the ratio is good, but I like to say multiplier, constant multiplier. So you're always multiplying by the same number. And then a constant ratio, that's talking about that multiplier, that number, we call it R. It's being multiplied by R every time. In a geometric series, remember when we talk about the word series, we're talking about adding up a sequence. So series is when you add all the sequence together. Okay, or the terms of a sequence, actually. All right. Let's take a look at example 1 here. In example 1, what's happening? 1, -4, 16, -64. Hopefully some of you are saying, oh, it's getting multiplied by -4 every time. That's what I need you to see. But to prove if it's geometric or not, I'm going to divide each time. Now remember, you're always dividing the second by the first, the third by the second, basically the number further to the right by the number to the left. So a sub 2 divided by a sub 1, -4 divided by 1, -4. 16 divided by -4, -4. -64 divided by 16, -4. So all of these are becoming -4. The ratio is -4, and it's geometric. You guys go ahead and do this one. Take a moment. All right. Looks like it's getting smaller, so it's probably multiplied by a fraction every time. I'm going to start all the way to the right and say, okay, 64 times what is 8? Or 8 divided by 64, that equals 1/8. Okay. How about 64 divided by 128? Oh no, that's 1/2. So we get another no. All right. The rule for a geometric sequence, a sub n equals a sub 1, the first term, times r, my constant multiplier, to the n minus 1 power. All right, so I'm going to use that information to write a rule for the nth term of a sequence. And here's the sequence. 972, that's a sub 1. So right here, don't be late for class. 972 is right here. That's a sub 1. R, what is it being multiplied by every time? Well, what I'm going to do is take any of these terms, like -324, and divide it by 972. And if I take -324 and divide it by 972, I'm going to get 1/3 as a fraction. On your calculator, you could just hit that math fraction button. That will help you with that. So my constant multiplier is -1/3. Okay. And it says find the 10th term. Well, to find the 10th term, I do 972 times -1/3 to the 10 minus 1 power, or to the 9th power. And I get -4/81. Okay. Easy enough. All right. One term of a geometric sequence is a sub 3 equals -18. The common ratio is 3. Okay. That means every time it gets multiplied by 3. So there's some number here. Here's kind of how I like to think about it. Let's do it down here. 1, 2, 3, and we said the third term was -18. All right. Some number times 3. See, the next number here is going to be -54 because the constant ratio is 3. So some number times 3 is -18. Well, that number is -6 times 3 is 18, and -2 times 3 is -6. And Negative 54 times 3 is negative 162. Okay, so that's how the constant multiplier works. But let's take a look at, let's do it the way they want us to do it, so you kind of see both ways to do it. So if we take a sub 3 and call it negative 18, put it right here, and we know our constant multiplier is 3. Hope we're not late. And then this is the third term, so we put a 3 there, 3 minus 1. Okay? Well, 3 to the second power is 9. Divide by 9, and a sub 1 equals... divide by 9, and a sub 1 equals negative 2. And that's what we had down here was negative 2, so we did it the right way. All right, so we get negative 2 times 3 to the n minus 1 power. Okay? And I already put all the terms here. And if you can imagine, if the last one made a line, I hope you guys understand that the next one is not going to make a line. The next one is going to make a curve. Okay, so because it's of the form, if you look at it, it's a power function. Power functions make curves. Now my leading coefficient is negative, so it's going to be upside down a little bit. If I go 1, negative 2, I got a little dot up here. If I go 2, negative 6, I got a little dot up here. I go 3, negative 18, a little dot up here. I go 4, negative 54, 20, 40, go here. And all the way down to 162 is down here somewhere. Remember, connect the dots or don't connect the dots. Don't connect the dots. Okay, you guys do the checkpoint on the next page. All right. All right. So hopefully you took a moment and checked that thing out. Now let's take a look here. We have 14, 28, 56. Looks like it's getting multiplied by 2 every time. And my first term is 14. So a sub n equals 14 times 2 to the n minus 1. Not too bad. Okay, 14 times 2 to the n minus 1. And number 3 there, we have a sub 5 equals 324. Now that's the 5th term, and my constant multiplier is negative 3. 1, 2, 3, 4, 5th term, 324. And my constant multiplier is negative 3. So I'm going to have to do some work here. 324 equals a sub 1, which I don't know, times negative 3 to the 5 minus 1 power, which is 4. 324 equals a sub 1. Negative 3 to the 4th power is 81. Okay, positive 81. When I divide by 81, I get 4. So a sub 1 equals 4. So that's a 4 right there. If I were to write all of the terms here, I get 4, negative 12, 36, negative 108, and positive 324. Now they asked me to find the 9th term here on each of these. So if I'm going to find the 9th term, I just put a 9 in for n. On number 2, it was 3584, and on this one, it's going to be big, 26,244. So I hope you guys got those. All right, let's take a look at example 4. Two terms of a geometric sequence are a sub 2 equals 10 and a sub 7 equals negative 320. Now this is a little more difficult than what we've been doing because they just give us those 2 terms. Can't really determine what the r is here until I do some work. So a sub 2 we know is 10 equals a sub 1, don't know that, and then r, and it's r to the first power because 2 minus 1 is r. Or 2 minus 1 is 1, and so it's just r to the 1. The other one here is negative 320 equals a sub 1, which I don't know, and r to the 6th power. Okay. Now, if I'm trying to find a sub 1, if I take the first equation and I divide both sides by r, I get a sub 1 equals 10 over r. And then if I put that into the second equation, if I put that information into the second equation, then I have negative 320 equals 10 over r times r to the 6th, or 10r to the 5th power, because the r to the 1 and the r to the 6 makes that r to the 5th. Divide by 10, and I get negative 32 equals r to the 5th. And now I take the 5th root, not sure why they skipped over all the work. Then I take the 5th root, and I get negative 2 for r. 10 equals a sub 1 times negative 2. Divide by negative 2, a sub 1 equals negative 5. Therefore, my equation is negative 5 times negative 2 n minus 1. That's a pretty tough one. All right, you go ahead and try one of your own. Checkpoint number 4 there. And you have to find, given these two things. All right? Go ahead and pause it and try it. Okay, so here's what you have. You have a sub 3 is 224, and that equals a sub 1 r squared. And 28 equals a sub 1 r to the 5th. Now, as we got bigger, our numbers got smaller. So I hope you notice that r is going to be a number less than 1. Right now, we should know that. Okay. Next, I'm going to take my first equation and divide r squared, and I'm going to get a sub 1 equals 224 divided by r squared. And I'm going to take that information and place it right here, right in the other one. So I get 28 equals 224 over r squared times r to the 5th, which becomes 28 equals 224 r to the 3rd. And when I divide by 224 and I take the cube root of it, hopefully after you've done that work, you find that r is a half. Okay, so you get a sub n equals some number for a sub 1, 1/2 to the n minus 1. And if you put that information back into here, you find that a sub 1 was 896. Okay, you can ask about that tomorrow if you need to. All right, and the sum of finite series. So this is the one where you're adding all of your terms up. This is the formula that you need to know for it. And so if they say find the sum of the finite series, some pieces you need to know. You need to know how to find a sub 1, and you need to know how to find r, or to spot r when you see it. So if we look at example 5 here, we got to first find a sub 1. So that means we're going to put a 1 right where I is. Well, I is 1 minus 1. Okay, a sub 1 has to be 4 to the 0. What would that be? And that'd be 1. 3 times 1 is just 3. 3 times 4 to the 0. Okay? R, in our situation, is 4, because that's the number you're getting multiplied by every time. So I put all this together. I have a sub 1, we said was 3, times 1 minus 1 minus 4 to the 13. That's going to be a gigantic number. Divided by 1 minus 4. So you put all that in your calculator. Notice that 1 minus 4 is negative 3. And this is 3 on the outside. So you know, those things are going to kind of cancel each other out. You're going to end up with 6710863. Okay. Go ahead and do the checkpoint on the next one. All right, welcome back. I hope that you were able to do all that same work and get 5, 6, 9, 6, 6, 1, 4, 7. And it's just filling in the blanks. Can you tell me what a sub 1 is here? Oh, it's 7. Can you tell me what r is here? Oh, it's negative 5. 1 minus negative 5, right, to the 11th. 1 minus negative 5 to the 11th over 1 minus negative 5. All right, and so that's how you got that. Great job, guys. We'll see you tomorrow.